They burnt 10 million coins at launch. That's what they did. 10 million coins. So they have 990 million. Now the difference between a proof of stake coin, right, and a proof of work coin, the amount of coins that you own doesn't dictate your voting power in the network. The only thing that dictates your voting power is the amount of hash power. So these are coins that are out of lockup for SAFT A and B investors, but their investors have not released them into circulation. This represents the holdings of over 50% of the original supporters of the project. They are available now, but we cannot predict and have no control over when they'll be released. I'll make a video on this tomorrow for you guys. Platform shares 200 million. This represents the coins that will be emitted as described above. Note that 3.7 million were already released on January 1st of 2021. So the remaining emissions are for 196.3 million Kadena over 9 years. Investors and strategic competitors. Well, hell, let's just go through it right now. I can't talk when I switch this screen, so we're just going to let this play out.
Update to the Kadena token economic model. On January 15, 2021, Kadena celebrated its one-year anniversary of the public launch of the Kadena public blockchain platform, the only sharded, scalable proof-of-work smart contract platform that can meet the demand of true industrial-scale operations on a blockchain. It's a good time to review the token economic model that drives the network, and we're happy to announce that we've revised our platform emission schedule to address inflation while still enabling us to provide economic infrastructure to drive growth. Token emissions. The overall emission of the Kadena platform happens through two processes: mining and release of allocated tokens. The vast majority of the overall emission is through mining. It's important to understand the timescale. Mining is incentivized by rewards for each new block that slowly decrease over time. At mining launch, November 2019. 2.018 M. Token/month. Today, January 2021. 1.94 M. Token/month. In 5 years, January 2025. 1.69 M. Token/month. This decay continues over a period that lasts over 100 years. So, while Kadena's total emission of 1 billion tokens sounds like a lot, it's more important to focus on the total emission rate. To grasp how the economy really functions in terms that are relevant to today. Here's what mining-based growth looks like from now, January 2021, until 2040. Platform emissions. The other source of tokens on Kadena Public come from pre-allocated tokens. Defined in the Genesis blocks, the first block on each Kadena chain that all subsequent blocks are mined from. A significant tranche of the token economic model is the platform share. Examples of uses of the platform share include developer and economic grants, as seen in our technical grant program. Community growing initiatives like our upcoming Community Ambassador program. Ecosystem initiatives to power the public network, such as the Zell Tech Flux Plus Kadena Node Operator program. Major ecosystem improvements like the Core Pact Web3 initiative. To run Pact programs on other networks like Polkadot. Even larger initiatives will be announced soon that could involve decentralized autonomous organizations, DAOs, or other community-led programs to fund major projects and economic initiatives. The platform reserve is unconnected to hash power and confers no governance or control over the network. Changing the platform emission schedule. The platform share emits 20% of the total emissions of the network, totaling 200 M tokens in the end. As specified in the Genesis blocks, this emission starts on January 1, 2021 and finishes by 2025, 5 years after network launch. The Genesis platform emission rate was designed to balance the need for strong economic support of major initiatives while recognizing that a slow emission rate is important for token economics, as well as to build trust in the overall project. The Kadena token model was designed and finalized in late 2017 and reflects best practices for Layer 1 platforms at the time. Indeed, as Masari noted in their Q3 2020 Layer 1 review. Kadena has the second most community-favorable token distribution amongst the top 12 Layer 1 projects. Crypto, however, has come a long way since then, and in 2021 the understanding of crypto economies is considerably more sophisticated. As such, and with a lot of help from our incredible communities on Telegram, Discord, Twitter and elsewhere, we've recognized that we need to change this emission rate for the best interests of the ecosystem. Why change the platform emission rate? Token economics are a relatively new field, but they can be analyzed using tools from existing currencies and commodities. A token like Kadena is emitted over time through mining and allocation release, and this can be compared to drilling for oil, mining for gold or minting new currency. All of these increase the supply of the product, which can interact with demand, such that oversupply can reduce the value of the product, and vice versa. In the case of something like oil, this can be a dominant factor, whereas with something like gold, supply versus demand is but one factor amongst many determining value. Nonetheless, all other factors being equal, reducing the rate of supply can have beneficial effects. Indeed, protocols like Bitcoin, Ethereum and Kadena all have decreasing mining emission rates over time in recognition of this principle. Today, we are announcing a reduced platform emission rate, effective immediately, that we feel strikes the best balance of our ability to aggressively develop the platform while ensuring that the token emission supports a healthy economy. It extends the emission timeline by 5 years such that emission completes by 2030, 10 years after network launch. With the adjustment, the total emission rate of the Kadena platform decreases significantly. To illustrate, let's look at the change in overall inflation for the upcoming year. Inflation rate Jan 18, 2021, Jan 18, 2022, old and new. Mining emission rate, 23% unchanged. Total emissions, mining plus platform, with old Genesis rate, 72%. Total emissions, mining plus platform, with reduced platform rate, 46%. These numbers are based on the total coins in circulation reported in the Kadena Block Explorer on Jan 25, 2021 of 98.8 M circulating coins, and a mining emission of 22.9 M coins in the time period Jan 18, 2021, Jan 18, 2022. The platform emission decreases from 48 M tokens/year to 22.08 M tokens/year. The fine print, implementing the reduced platform rate. Genesis blocks cannot be changed without a difficult and risky hard fork. However, allocations are released manually into circulation on the Kadena platform through the operation coin.release allocation, which is only allowed to be executed once a given tranche is unlocked. For the platform share, this is a monthly event. Thus, the new platform emission rate represents our affirmation that starting with the upcoming Genesis platform release on February 1, 2021, Kadena will not exceed a platform coin release rate of 22.08 M tokens/year and 2 M tokens/month. Kadena reserves the right to further modify, decrease or increase the platform emission schedule in the future for what Kadena believes is in the best interests of the platform, Kadena, and the ecosystem. Overall token allocation model. While the overall Kadena token allocation model is unchanged, we'd like to take this opportunity to provide all the data in one place. Mining share, 700 M. This represents all coins that will be emitted through mining over 100 plus years, as described above. Platform share, 200 M. This represents all coins that will be emitted as described above. Note that 3.7 M was already released, on Jan 1, 2021, so the remaining emissions are for 196.3 M KDA over 9 years. Investor, strategic, and contributor, 90 M. The remaining coins are dispersed into numerous tranches, as follows. Series A and Series B investor sales, 21.4 M tokens. 2019 CoinList offering, 2.1 M tokens. Contributor share, for employees, consultants, advisors, 30 M. Note that 39% of these coins are already distributed with the remainder held in trust by Kadena. Strategic share, for ecosystem initiatives and future sales, 36.5 M. M burned at launch, 10 M. The Kadena platform was launched without a planned 10 M tranche for the strategic share. Total coins in economy, 990 M. This represents the planned amount of 1B coins, minus the 10 M burned at launch. Current circulating coins, 98.8 M, as of Jan 25, 2021. This represents all coins either mined or released from allocation, and also represents all transferable coins in the system at the time, as reported in the Block Explorer. Unreleased investor coins, 10.98 M. These are coins that are out of lockup for SAFT A and B investors, but the investors have not released them into circulation. This represents the holdings of over 50% of the original supporters of the project. They are available now, but we cannot predict, and have no control over, when these will be released. Locked non-platform coins, 16.05 M. These are coins that will be coming out of lockup in the upcoming year at various times. Investor locked coins, 2.38 M. Strategic/contributor locked coins, 13.67 M. Conclusion. At Kadena, we're going into 2021 with exciting projects nearing completion. The multi-protocol DEX, Kadena Swap, is wrapping up an incredibly productive run in testnet where the community stepped up to find all sorts of issues and great suggestions for improvement. Chainweb 2.4 released on Jan 15 with native support for Ethereum and Ethereum compatible. Bridges, representing the most difficult milestone for erecting bridges to Ethereum, Celo, Terra and beyond, with the next step being setting up our bridge relay program, and launching wrap tokens. With this announcement, we seek to similarly turbocharge our token economy to leave no stone unturned in our quest to prove out Kadena as the best platform to take crypto into the new decade. If you have questions or comments, please join the discussion. Outside of Medium, you are invited to engage with team members on Discord and Telegram. Update to the
So don't quote me on this, but I'm pretty sure I've interviewed them and I've asked them were there any pre-mined coins. And how I think that their emission schedule originally worked was that at some point, when you hit a point, like as they're mining, the miners are like a percentage of that miner reward goes into basically a locked contract. So you're getting, like, the early investors are getting coins, but they weren't given them at launch, if that makes sense. Like, as the miners are mining, the miners are adding tokens to a contract, and that contract is staying locked. And then after a period of time, those coins unlock, and then you have them. If I'm not mistaken, that's how it did. If that's how they did it, but don't quote me on that. There's another video where I showed over here. Damn, where is that video? Man, now y'all making me nervous. But with Kadena, if they label everything as security, I think it's going to destroy the industry. So, like, what makes Bitcoin a commodity is the fact that it's mined just like gold or just like oil, right? You have to buy equipment, you have to put it to work, and you have to do so, right? Yeah, it's a good question. Yo, Crescent, what up, homie? Appreciate you, my dude. Let me see if I can find that video here where they talking about it at launch. Ah, here it is. Here it is. Okay. So this video right here will show when they were doing the funds. I think it was the interview on CoinDesk, and Will explains on how they did their funding rounds. Martino and his experience in the blockchain industry. He is one of I personally think he'll go down as one of the greatest minds to ever enter the space, with the likes of Stuart Popejoy, Stuart Habert, Scott Strom. The challenge is our experience at JP Morgan graduates interview, private blockchain minds. The clip
of the token sale. So tell me a little bit about how the token sale has been running on CoinList so far.
So it's been going well so far. We can't go into too many details just because of regulatory concerns, but CoinList has been a great partner in getting the token sale off the ground and bringing people in. It goes on for another 2 weeks, and this is the sale that is right before the main platform launch, which is on December 5th. And it is kind of this initial period when the system is booting up and we're starting to get more and more people involved. The interest has been interesting. It's been global. And people have been looking at the way that things are structured and they're liking what they see overall. Like, between them and the miners have been loving us. And then people have been looking at the rounds and have been like, this makes some sense. This is a new.
You catch that part there where he's talking about doing their initial round, right? But he's talking about the miners already loving us. As if the platform was already live, the miners were already running, and now they're starting to raise the capital. Because I think of how they structured their blockchain to put out rewards. Like, those emissions are built into, like, when you're mining Bitcoin, right? And you mine a block, the first transaction of that block is the miner reward address from the block before, right? So when Bitcoin gets rewarded, right? When you solve that block, when your miner is the one that solves that block, what the blockchain allows you to do is you put your address in the first transaction in the next block is your address. So when you solve a block, the next block pays you the rewards from that block, right? And in that rewards, in those block rewards, you can structure it out however you want. Like they have an emission schedule. And so as those minor rewards are released, and so is their emission rewards. And I'm pretty sure that that's how it was structured. And that's how they got around, quote unquote, the pre-mine thing. But this is a really good question. If anybody else gets a chance to interview these guys, or you see them on Twitter, that would be a great question to ask Doug in one of the Twitter spaces. So maybe we can ask it on Thursday. Is Doug still doing those? I don't know if I've just been so busy I haven't been paying attention, but I haven't seen one lately.
Strategy for how to do this stuff, and yeah, I think that this could work. This might be what comes after IEOs.
Well, I actually think that it's interesting that this sale is open to US accredited investors, which is a strategy that you had taken by doing 2 sales side by side. Do you want to talk a little bit about the sales strategy in opening up the token sale to US accredited investors?
Sure. I mean, getting the US involved is a very important thing, and the way that we structured the Reg D offering is one where you can get in at a very similar rate to our early investors. We don't believe in launching an application or launching a network with a multi-billion-dollar market cap where VCs are already 30, 40x right at launch. We don't think it's healthy, and I think that the market's proving that out. We take a very different approach, which is launch with a very low market cap, because we want to be able to gather as many people who are interested in the platform as we can early to help us build the thing into something great.
You don't hear that much in this industry. Everybody else in this industry is all about the money grab. How much capital can we raise up front to launch with an extremely high market cap? That way our early investors, our VCs, can take profits. They're all happy. That way, when price dumps down, guess who steps in and buys the dips after they convinced all retail investors to FOMO in at peak formation? This is just things that you don't really see in this industry. And I also want to point out the fact that Kadena was launched in 2016. No coins were ever sold anywhere until 2019. So 2 years later, and this is December of 2019. So I want to say 2 years, no coins were sold. They sat there and they built Kadena, didn't market it, didn't do anything, just built it, and sat there for 2 years. Then in 2020, they started to sell to accredited USA investors. And that's also something that you do not see any other crypto project doing. So when we talk about regulations and securities, assuming that Will worked for the SEC, probably had a good understanding of what they needed to do perfectly, precisely, to make sure that they could not pass the Howey test. And let me be clear on that. You want to fail the Howey test. You do not want to pass it. If you pass it, you're a security. And then you also hear him say there that they built a network, not an application, not a service, not a software, a network. That's what Kadena is going to be. Kadena is going to be the internet. Anything that you want to build on it, any application, any app, any software, any service, you're going to be able to do that on top of Kadena. It's cool. It's crazy.
Speaking of other platforms, I know today you guys are announcing this partnership with the Web3 Foundation in building for the Polkadot blockchain. So tell me a little bit about how that came about and why the Polkadot ecosystem.
Yeah, it's been very interesting talking with them. We started talking with the Cosmos Foundation a while back, and have already done some work to put Kadena Mint, which is Pact on top of Tendermint, into at least a first version. We're continuing to work with them and expand out the feature set, also integrate it more broadly with our ecosystem and with theirs. And we started talking with the Web3 Polkadot people, and they were very interested in looking into seeing if we can get Pact on top of Polkadot as well. Pact, Kadena doesn't believe there's going to be one chain to rule them all, but we do believe there's going to be one smart contract language, and this seems to resonate with a lot of people. Smart contract languages take years to build. There's no real, there's just a lot of magic that takes place to actually build one that really works and that is the right structure. So once you have something that works, so long as it's embeddable, then you can start putting it on other platforms. And Pact from day one was always designed to be embeddable on different consensus protocols. We put it on our private blockchain first, Kadena Kuro, and then we put it onto Chainweb, and then we put it onto Tendermint, and hopefully we'll be able to figure out how to put it onto Polkadot. And the lovely part of it is because Pact on Chainweb needs so much interoperability from just out of the gates, because of multi-chain architecture, it already has most of the tools that you would need to go from, let's say, Cosmos to Kadena mainnet to Polkadot parachain, perhaps, to something else.
And this is where we're going to wrap it up right here, because I have to do a little bit more research, but I want to show you guys the videos where you quite possibly may or may not be able to settle transactions from any chain using Pact on top of Kadena. Now, Kadena Tendermint, I believe, is already live now. So I'm going to show you guys another video. We're going to walk through what that might mean for this industry or what it could mean. But again, it's way over my head. So makes sense. So I can't answer that about the pre-mine, but I'm pretty sure that's how they did it, because I'm almost positive I wouldn't be over here saying no pre-mine if I didn't ask them that in an interview. But I've interviewed them so many times and I've asked them so many questions I can't remember. But that's a great question to get clarified in one of the next live streams. And I almost think that it's something that they kind of don't want to talk about, because how they did it, I would assume that they don't want to. I wouldn't want to spill the beans. I wouldn't want the SEC. Yeah, it's really good, Paul. I broke it down the best I could. I've even, like I said, I've consumed, I would say 90% of Kadena content that's ever been created. There was like a 2-month period here where that's all we did every night. Everybody in the squad, we researched every video, we studied every like I've done over 1,000 hours, and it wasn't really until that 1,000th hour that I even had to put out an apology video, because I was giving them a hard time for them not having this done and not having that done. But the real trick, the real sauce here, right? You guys want to see another one? The real sauce about Kadena and what sells Kadena and why Kadena is 100,000 times more superior than anything else. And it's called formal verification. So if you don't understand blockchain technology, you don't understand how to write your own smart contract, you don't understand that Ethereum smart contract coding language is trash. And I don't say that to bash Ethereum. I'm saying that because it's a freaking fact. It's the truth. They knew it in 2017. They know it today. Ethereum formal verification is the secret sauce, right? So if I were to pull up ChainWeb, I would have to log into it to, I'll do it for you guys. It's just such a pain to do this. I wish they just had the copy button. So if you want to code on Kadena, this is the first thing you got to do, right? You got to start, you got to create yourself a dev wallet. And this is like, you guys are going to get your mind blown, right? Like I was able to teach my 8-year-old son how to write a Pact smart contract. You just can't do that in any other blockchain. It's just a fact. I don't know if it's going to add that space in there. If it does, I'm going to be ticked off. I think it just did. I got something wrong there, didn't I? Oh, I messed up there. I gotta show you what formal verification is for you to actually understand it, because I'll play the video, but it just won't make sense. This is why Kadena melts faces, and unless you really understand tech, you don't understand what I'm talking about. So I gotta show you. Once I show you, you're gonna want to sell everything else in your wallet, and you're gonna sell every ERC20 token. It's just, It's asinine that I'm the only one in the industry breaking this down. And this is when I got so upset with like just watching the other influencers just shill these other projects, that when you compare them to Kadena, you're like, what are you shilling, dude? Like, what are you doing, man? It's like it's like night and day. All right, so now we got a Chain Reaver wallet created, right? This is the secret sauce. So this is your REPL, right? This is how you write smart contracts. This is a line of code here. So we can go into the Modular Explorer over here on the right. Let me just bring it down for you guys to see. So this is your Modular Explorer. So say I wanted to open up the Hello World or Hello World key set module. I double click it, right? So the first thing that it's going to do, how do I show you guys this? All right, there you go. So right here, right now, see this red line, this red arrow right here, right? This little red box. Not only does that red box tell me, hey, dumbass, right? On screen, bro. What? On screen. Yeah, dude, I just made up a test wallet, guys. You guys want to steal the wallet that has no Kadena in it? Yeah, y'all think I'm opening up a wallet and giving you guys my private keys on screen? Y'all crazy, man. It's a dummy wallet. It ain't got nothing in it. It's a dev wallet. I know what I'm doing. You guys can feel free to jump into this Chainweaver wallet, guys. I promise you're gonna get nothing but air. Yeah, you guys want this wallet, man? I'll sell it to you. First person to drop, first person to send 50 Kadena to my other wallet. It's all yours, man. Y'all crazy, man. Nah, guys, I got you guys. That was my wallet with 22,000 Kadena in it. First person to get those keys gets it. Ah, you guys funny, man. All right, so where are we at here? What did I do? Oh man, how you guys got me messed up here. What did I do? Did I change something? All right, let's come back over to these contracts page. All right, so see this red box just pop up here, right? So what Z3 is, right? Is it Z3 technology? And this technology was created by Microsoft. And the purpose of this is kind of like the traveling salesman. So have you guys ever heard the traveling salesman problem, right? You got a salesman, right? And he's got to go to 15 different houses, right? And they're all in the same town, right? But he's got to start at this position, right? He's got to start at house number 1. And he's got 15 different houses on a map. So we can pull this up and let me make a little diagram for you. Let's get real techie on it. Thanks for having my back, though, squad. I appreciate that big time. I'm not going to put 15 houses here. You guys are going to get the idea. These are all houses on a block, right? So if the salesman if our salesman starts at house 1, right? What is the fastest way for this salesman to go to every house in the shortest amount of time? Right? To do that math problem, it's such a long process because you have to measure from, it's like, these are like winning lottery tickets, right? Like if you want to win the lottery and guess 6 numbers, Like statistical probability, how many different routes, how many different ways are there for you to win the lottery? You don't have to get in the exact order. You can get ball number 2, number 7, number 9, number 8. You guys get what I'm saying? So you would have to measure from every route. You'd have to go, okay, he's going to start at house number 1. He's going to go to 2. And then you have to do the whole course, right? And then you have to see, and you have to add it all up at the end result. Like, what is the end result? All right. So he went from 1 to 7 to 6 to 2 to 3 to 4 to 5 to 8 to 9. All right. That was, 1,000 miles. All right. Well, what if he went from house 1 to 7 and then to 2, then to 6 to 5 to 4 to 3 to 2 to 8 to 9? You have to go through and you have to measure every single freaking route. And they call it the traveling salesman because 9 houses, yeah, you could probably figure it out in a decent amount of time. But give the UPS driver 100 different houses that he has to deliver mail to. You guys get where I'm going with that? Like every time you add another house in there, every time the salesman has to visit a new location, the problem gets that much more complex to figure out from the very beginning. You need like a super computer to figure it out. So when you're coding, right? When you're coding in Kadena, number 1, what's the first thing you guys notice about this smart contract right here that's completely different than any other blockchain? And it's the most important part. Anybody that's not in the squad, like somebody that's new here that doesn't have a membership, that's just learning about Kadena, what is the first thing that you notice about this smart contract versus this, what you see on the screen here? No, not that one. I had it right the first time. Right here. What is the first thing that you notice different about this smart contract than this smart contract? Right? After a Solidity smart contract is executed, it's compiled and it's turned into bytecode. So I can tell you that my smart contract for the Bored Apes NFT mint only had legit code in there. But what you're going to look at to try to audit that smart contract is this. You're going to look at the bytecode. It's a bunch of 1s and 0s. There's only like 2 or 3 people in the world that can actually read this, right? 6086642, right? It's called bytecode. It's not in human readable code. The first thing that you notice about this Kadena's smart contract coding language is the fact that you could teach an 8-year-old in 10 minutes. Well, it's actually 11, but if we weren't have been dicking around, it would have been 10. How to write a Kadena smart contract. And then most people watching this stream are going to go, dude, you're crazy. An 8-year-old couldn't write a smart contract.
Click open hello world.
Yep. Can you talk a little louder into the mic?
Open hello world.
Yep. All right. Now. All right. Step 3 is what?
Click NV tab.
All right.
Change admin key set to Mason key set.
Yep. So that's my son, right? In 10 minutes, I taught him how to write his own Pact smart contract. Right there, he was saying it was really quiet, but he was saying you need to change admin key set to Mason key set. And that's the first step in Kadena when you're writing these smart contracts, right? And how is it so simple for him? Because it says it right here. So what this is using is it's using Z3, which is called, it's a technology created by Microsoft. And the purpose of this software created by Microsoft. I need one more thing. So taking a look at this maze on the screen right here, what is the fastest way for you to get from an entry point to the center of this maze, right? Do you enter here? Do you enter here? Do you enter here? Do you go left? Do you go right? Do you go... What is the fastest way to get to the center of this maze? You couldn't tell me because you'd have to go in here. You have to measure every point, right? And go from every point and try to figure out, oh, nope, that way is not the fastest. All right, go back up. All right, can we go this way? Yep. All right, cool. We can go, nope, right? So what Microsoft did is they've created a software which basically analyzes 1 billion data inputs every second. And what is it looking for is it's looking for a way to break your code. So what's really cool is when you wanted to write this smart contract right here, not only does it tell you, hey, if you're trying to execute this smart contract, you don't have the admin key set. You are not the owner of the admin key set. So to control the namespace free, you can't be you have to have the admin key set. What's cool about it, you're like, oh shit, I don't know how do I make an admin key set? Well, why don't I just come over here and click the fix button? Boom. Now I'm the owner of admin key set. Bam. That simple. Or I could come over here and I could change admin key set to meta key set, right? And now it says, right? And you have to come through here and you have to now since I'm defining my key set, right? I'm saying, hey, I want to define the key set that controls this smart contract and this namespace being free, right? And I want to define the key set as meta key set. But after, what is it still trying to do? It's still trying to read the admin key set. So I come over here and I change this to meta key set. And boom. Now what's my error message? Oh, don't have a meta key set. Bam. How would I fix that really quick? Boom. Error fixed. Smart contract able to be executed. Like literally 2 simple seconds, right? It's so crazy how easy that is. Now, when you watch this video, it's going to really explain what Z3 is and what formal verification is. Man, I can't stand my mic. I can hear my mic cracking there. I can't believe you guys didn't say anything about that for so long. I don't even know how to fix it. I have to use this NVIDIA thing on here to fix that. So you guys don't hear that. All right, ready? Better than other blockchains. What makes Kadena so special? Why is everybody not talking about Kadena? Once you start to study Kadena's technology and you realize what Kadena actually is and how powerful this smart contract language is going to be and what it's going to do for the space as far as making things safe, secure, a coding language that audits itself instantly and can analyze a bazillion outcomes in a matter of a second, in fractions of a second, and come back and analyze your code that you just wrote about your blockchain and give you any area where the code could be flawed, where there could be a bug or an error that unless you manually go and test out 1 billion different scenarios with Ethereum, you're just never gonna know, right? And that's why so many hacks happen in Ethereum. Think about this industry, right? Blockchain's supposed to make things safe, secure, transparent, but yet every day the hacks get bigger and bigger. People are losing more and more money. More and more applications are breaking. They can't scale. They can't work. We've seen the industry try to come out with some great idea. Titty twister rollups, moped compression algorithms, Johnny Dow's pizza oven, where if you stake 37 salami nipples, you get a frickin' Martha Stewart little cookie cooker. I don't know, guys. It just seems so goofy to me. Why wouldn't you want to code in a language that's human readable, that audits itself, and that has formal verification? Ready? Let's dive deep. So in this first video, I'm gonna play a quick clip of what is formal verification to get you guys like an idea of what formal verification means. And then we're gonna watch one more clip after that that'll really explain it and you can actually see the code auditing itself. This is a video by Galois, G-A-L-O-I-S on YouTube. Swing down in the description. After this video is finished, you'll find a link.
Software. It runs our world, becoming more sophisticated and infinitely complex. From our cell phones to our cars to our medical devices, we trust our sensitive information even our lives, to a complicated maze of algorithms. Where safety and security are critical, the repercussions of insecure systems can be catastrophic. Even with rigorous testing, there are countless ways for things to go wrong. So how can we make these systems safe? By going back to first principles and mathematically proving that software is correct. Just like a builder who relies on a blueprint for construction, programmers rely on a critical system's specifications outlining how it should and should not perform. These specifications are translated into coded instructions. But often, the specification and code do not match up. This causes flaws that lead to breakdowns, malfunctions, or cyber attacks. With formal verification, we can analyze deep properties of the code to prove nothing is lost in translation, and that the software does only what it's intended to do. We do this by converting both the code and the specification into mathematical representations, which are then checked against each other by mathematical proof. If they do not align, we isolate the cause of the mismatch and correct it. Imagine an elaborate maze. Now multiply it by billions. The number of possible routes through the complicated maze of modern software is larger than the number of atoms in our solar system. With conventional testing, it would take thousands of years to test each path individually for flaws. Therefore, critical routes are often missed. Formal verification allows us to evaluate all possible scenarios and the entire state space all at once. As a result, we eliminate entire classes of flaws, dramatically improving the safety and security of our critical systems and greatly reducing costs down the road. These days, we trust our most critical systems in ways they don't deserve. By formally verifying both their design and implementation, we can prove correctness in systems where failure is unacceptable.
You guys get what he was saying here with this maze, right? So when he was showing you this maze here, if you wanted a computer basically, or a human, to go through and figure out what is the fastest way to basically get through this maze, you have to know every area where you fail, every area you can't go. In order to map that out and find out statistically the best strategy, you'd have to be able to analyze all outcomes. And Microsoft created something called Z3 or Z3. And it's basically a software that can do things like that. Kadena built Pact with human readable code. So this video is like 6 minutes. We're actually gonna watch him explain how formal verification works. It's really sick. And how you can use that when coding. I will watch both 1 and 2 because they're both really good.
We're using a library wrapper called PySMT, which by default uses the open source solver called Z3. And we're setting up our problem by saying we want to have a group of letters made by the set of hello and world. And hello is every letter in the word hello, and world is every letter in the word world. And then our problem space here is we're telling the solver it's got to find a value for each of the letters that has to be greater or equal to 1, less than 10 for all those letters, that all of the letters, the assignments have to be different, and that when you add all the letters up that make up the word hello, they've got to equal the same sum as all the letters added up in the word world. Then we print out the serialization of the formula, and then if we do get a result, we'll print that out. Otherwise, we print no solution found. So let's see how that works. So you can see the serialization of the formula here. And this first part is making sure that each of the letter symbols is getting more than or equal to 1 and less than 10. So that takes us all the way to here. And then this second part is saying that each of the letter assignments has to be different to each other. And that takes us all the way to here. And additionally, that the sum of all those letters has to equal the sum of all those letters. And it's come up with a solution with these integer assignments to these symbols that satisfies our problem. And so the solver is satisfied, so we get the result.
So do you guys get that? He took the word hello and the word world, and he wrote a line of code and he says, hey guys, I want this software to actually find a solution on how I can assign one letter with one number I can't, this like E couldn't be 8 and D couldn't be 8, right? You had to use a different letter you had to use a different number for each letter, and you had to use numbers 1 through 10. You couldn't go above 10. So next he's going to show you where a bug would be.
Solution is found. If we change this so that it can only assign more than or equal to 1 and less than 5, by inspection we can see this can never work, because we're also saying that all the values have to be different, and we've got more than 5. We've got more than 4 letters in both hello and world. So if we now run this, we get no solution found. And this is an interesting point with formal verification. When the solvers work, they give you a true or a false answer. There's no gray area. There's no possible solution waiting if only it waited a bit longer or it had looked in a different place. It's either it's found something or it's not found it, and that's called exhaustive.
So why this language that we call Pact? That's the name of the language we wrote. Our ideas about what a safer language is one, that it's interpreted. That means that, at any point in time when you're talking about what code is going to execute, it's the code you wrote. It's not some lowered version of it. It's safer also in this idea that we got from Bitcoin of that it's good to have something that's Turing complete that will always terminate. It's simpler in that it really just tries to do database and authorization and a few other things. It's safer in the sense that it doesn't allow you to reassign variables. Lastly, it's easier in the sense that once you write code in this, you get an API out of it for free. One of the things I'm trying to talk about here is that we built all this in Haskell, and Haskell is this amazing language for writing languages. That's why I'm trying to get into really the motivations and the design of this, so that I can empower all of you to think about how you're going to use Haskell or OCaml or any of these languages to write languages that don't necessarily look like Haskell or OCaml, and why would you want to do that? So what was interesting about that experience is that we were writing a type checker that wasn't for the runtime environment. We were writing a type checker kind of just to have a type checker, and also for this one particular path in the tool chain. We're using this smtlib compiling library. I should have put that in the library list. I don't know why I didn't do that. And again, the reason why we're able to do this is that we're already a form of single assignment semantics, or SSA. We have no recursion. Our code is all, once you load something into our environment, it already gets inlined, which is one of the things you have to do. Since we have no recursion, that's easy to do. And so we built this type checker to output a typed AST, and that made it possible for us to start using, this is a little hard to see on the monitors, but basically, if you take like a typical Bitcoin function, it doesn't turn into much more smtlib2 than this. I mean, there's more, but it's just interesting since smtlib is a Lisp itself. It was just kind of fun to see that we could actually do this in a reasonable amount of time. But one of the problems you run into when you start talking about formal verification is that we want to get formal verification to the masses. We want people to actually be using formal verification to make their code better. And that's a tall order, because most people don't understand what formal verification is. It's just a very hard concept to understand. So remember what I said is that we don't have an immutable language because we have this huge global variable called the database. So what we decided was, let's make a little DSL within Pact, doing a kind of doc test Python-esque thing where you put something in the comment to declare what you want to prove. And let's give you let's give you range stability, and let's give you mass conservation, which is basically a net zero kind of thing. We want to say that, this is an important thing in, kind of actuarial land, which is you want to say that anytime you take money out of the system, you put money back into the system. We're calling that mass conservation. So let's look at how this works. We have a function here. We have a module. So Pact, everything is in modules. That's how you define a service. It goes on the blockchain. You've got this nice service. So maybe we have this account service. But here we're just calling it analyze tests as the module. And we have a function called pay. And in the pay, we're basically saying that we're going to prove that the balance column conserves mass and that it never goes below 0. That's a very tangible thing that would be very nice to be able to say about your database, because it's like, we're trying to keep track of money here. We want to make sure that we never double spend. And in this case, we don't want overdrafts. So we want to make sure that the balance column is always greater than 0. Of course, there isn't that much code, right? This is a really, really simple function. So duh, I mean, there's no bugs here. We have read. We have read. We have enforce sufficient funds. We have write. We have write. I can look at this code and I'm like, looks pretty good, right? But whatever, proving is cool. So we're going to prove some stuff, right? So here we go. So first, what we do is we do the compiler. So the compiler spits out smtlib. So it's going to capture every variable in there. I mean, this is another thing where Lisp is great because, you know, Lisp just makes scoping as freaking obvious as it could possibly be. You know, so it's really just like, and you know, and by the way, we really are Lisp. We have let star with the whole confusion about whether to use let and let star. We have way too many parentheses. It's a real Lisp. So anyway, so we're going to declare all this stuff, and this is where the money part starts, right? So so we're using Z3. Z3 got open sourced by Microsoft about 2 years ago. It's blazingly fast, but it's relatively new on the scene because it was closed source, so people weren't using it in academia and stuff like that. But it's freaking amazing. I mean, what it can do in a very short period of time is it can basically simulate the entire universe of inputs and then try to break something for you. So what we're going to do is we're going to make assertions that we want it to prove false. So we're going to assert, in the case of conserves mass, we're going to take everything that represents a write to the database, and we're going to take everything that represents a read from the database, and we're going to add those, and we're going to try to say that they always have to be equal. And that's just a way to formulate mass conservation as a math problem. And we put not in front of it so that we say, Z3, tell us if this is ever possible that we could write the wrong thing to the database. Same thing with the range. We're going to basically do an assertion of an or that any of these things that end up being updates to the database are we say greater than or equal to 0, and then we put not in front of it. And again, we're going to call checksat, we're going to call checksat, and we're going to have Z3 ruin our day. So here we go. But remember, that code was great, right? We looked at it. It was awesome. It had no bugs. So here we go. So the first one, we conserve mass. We know how to write code. It's great. Unsat. Yay. Second one, sat. And in fact, this happened with this because this was a code that was in our open source repository. We're like, Z3 sucks, or we can't write smtlib. There's got to be a problem. No, our code sucks, actually. Amount. All you have to do is pass an amount of -1, and it's broken. It's a bug. It found a bug. Now, what's interesting about Z3 is Z3 doesn't give you the range of all possibilities. It's not a prover in that respect. It's not going to like show you all the ways you're fucked. Excuse me. Screwed. It's going to show you exactly one way. It's going to give you a model. It's going to give you a model that says, here's how things aren't good, right? So -1. Well, what does that tell us? It tells us that we left an invariant out of here. So again, we have this thing called enforce. So let's go in, and let's make sure that our amount is greater than 0. There's a bunch of loosey-goosey stuff in Pact. Like, we'll do like coercions and stuff like that, because you know that's what C programmers are used to. So, and then we're going to say something like amount greater than 0, or amount less than 0, or whatever. Who cares? By the way, this makes us better than Ethereum, the fact that we have error messages. All right, so are we in? OK, so now we just make sure it compiles. We just put in that little fix. It looks like it compiles. So then we're going to pass that into ZM3S3. Unsat, unsat. So I just want to point out, yeah, I mean,
this is why I don't talk about Kadena much, right? Because I don't have to. Everything that you want to learn that I've ever learned about consuming 1,000 hours of content, including going through the best interviews and highlights and clipping out all the best pieces that will help you understand this technology better, they are all in this playlist. I don't know why that one's in here. Weird, why are those ones in there? But anyways, those outside those two videos, I mean, this is, and then you can hear Stuart talk about, it's just, I could go on about it for days and explain every detail to everybody, but if you just watch these playlists, you're gonna make through it. How many people have asked me to make a difference between a proof of work and a proof of stake video? Proof of work, proof of stake. It's in the playlist. I've showed this playlist so much. You want to onboard, you want to pink pill people with Kadena, all you gotta do is get them to watch this entire playlist, and by the end of it, none of these other influencers will come on my stream and debate me about Ethereum, right? I'm open to have an open conversation. And the only thing that anybody says is like, bro, you really think that the biggest layer 1 blockchain, the number 2 blockchain in the entire world, you think it's really going to be irrelevant? I go, yeah, I do. 100,000%, because you have to be crazy to be a business and go, I'm going to code in Solidity after this, right? This is the nail in the coffin for can I see the pages, man? Ah, there they are. This is the nail in the coffin for Ethereum. It's just this simple, guys, right? No bank, right? 14 billion in hacks, and these are just hacks, right? They didn't put the Time Wonderland in here that I know of, right? And that was what, like a $2 billion meltdown. Like when these guys build these projects that have market caps of $2 billion, or they launch with a market cap of $56 billion like ICP, and then it goes down to 5 billion or 2 billion. No, that's not in here yet. And that's what blows my mind. They're not talking about the projects that raised $58 billion market caps and now they're down at 1 billion and they're never going to go up again, right? If that project just slowly bleeds out and eventually just runs sideways and nobody touches it, it doesn't count as a scam, right? And that's why I say that the best scams in this industry, or I shouldn't say scams, the best designed money grabs in this industry are the ICPs, right? Take a look at what ICP did, right? They launched, this is the market cap today, 1.5 billion, right? Do you remember when this thing launched with a $46 billion market cap? It was actually like a $57 billion market cap, I think. 57 billion. They were able to build a project. They were able to build an application that generated and raised capital or launched with $46 billion worth of retail investors' money in it, right? And now it's worth 1 billion and ain't nobody gonna use this, in my opinion. Now that's just my opinion, no facts, whatever. But to me, this is what I consider a money grab. You build a project, you get a good team of people, and you can raise insane capital. How does a product like ICP launch with a $45 billion market cap? And people watching this video think that a node project that was going to add smart contracts to Bitcoin, or then it was going to be this Web3 project of the future, and then it was going to be this. It's always something else with this project. Yet all it's done is just cost people lots and lots of money. And if we take a look at their source code, that one's updated 15 minutes ago. So there are still people in a compute source code client software run by, let's talk about Awesome Definity, 14 days ago. Okay, so they are still working on this project. It's not completely dead. 5 hours ago there, it's actually very active. So, but is anybody going to use it? I highly doubt it. I highly, highly doubt it. Then you take a look at something even like, you know, I could go on and on and on about every single product in here. And you see projects like that sitting up in the billions of dollar market caps. And you're talking about the most advanced smart contract coding language in the world. And what, like, nobody's going to build anything on Ethereum because every layer 2 application just get like 14 billion in hacks in 2021. 14 billion, guys. Which is up 567% from 2020. So at that rate, like if we went to another bull cycle in 2023, oh my God. I mean, we're in the most bearish market in the history of crypto. Insane. So you think anybody, like I don't mean like a couple dudes that live in their mom's basement that met a couple dudes in a Discord that they've never met before, and they got a team where you can build out something in Solidity because all you have to do is go over to GitHub. Like say I wanted to fork ICP, perfect example. Right, there's one up here I just saw that I've never even heard of. What is this thing called? It was like number 11. What is Unsus? Unised Leo. Unised Leo has a $5 billion market cap. I've never even heard of it. Like, where did this thing come from? It's an application built on top of Ethereum. And it launched in 2019. And it's like outperforming everything right now. It actually just put in a new all-time high in April. Like, what is this thing? I've never even heard of Bitfinex.com. Oh, it's Bitfinex's coin?